everyone. I'm Magduma Sayed on behalf of Computer Science and Engineering Department, Parul Institute of Engineering and Technology. Welcome you all in our webinar on serverless data processing by Mr. Harsh Patel. So today we have our alumni, Mr. Harsh Patel from Toronto, Canada. So on behalf of Parul University, Harsh, I welcome you. And Harsh completed his bachelor from Parul University and he did his master's from Dalhousie University, Canada. He has experience on various programming languages like Java, Python, C++, PHP, etc. And currently he is working as a software engineer in Achievers, Toronto, Canada. So again, Harsh, I welcome you and I would like to request you to start the session. And if I request all the viewers, if you have any query or questions, kindly ask your questions on below email ID magduma.sayed2810@paruluniversity.ac.in. Thank you.
Hi everyone. I'll start presenting my screen now. Yeah. Just to check, can you see my screen?
Yes, Harsh, it is visible.
Okay, I'll start. So, hello everyone. My name is Harsh Patel, as Magduma ma'am has already introduced myself, and today is a seminar about serverless data processing, and it's a 1 hour journey which I'm going to take you to. So just bear with me for 1 hour. And firstly, I would like to thank Magduma ma'am and Parul University to give me such an amazing opportunity. And so we'll start our seminar. Firstly, I'd like to say that I may not be a master on this subject, and I may make some mistake while the seminar is going on. So if you want to correct me with anything, I would be happy to accept it at the end of the seminar. So just forgive me in advance. And it's a bit tricky to present without seeing the audience, so you need to bear with me for 1 hour. So let's just start without wasting time. And why serverless computing and how serverless computing? So just think about how you were building your web apps in the 90s. You were using physical hardwares. The physical hardwares, you need to own it. And it was not cheap at that time. And then you had to do all those server configurations, and it used to be expensive. You used to manage all the things by yourself. And then after you go through this whole hustle, finally, you need to keep your server running for 24/7, which is not a small task. So it was not that easy. And then came the initial cloud computing days in the early 21st century, I would say around 2008, 2009, where big cloud providers started giving cloud computing services. And so the main advantage was that now physical servers were not needed. Now, virtual machines were provided by cloud computing providers such as Google, Amazon, and Microsoft, and all those companies. But so there was one advantage, that you do not need the physical hardware. But then the other thing which was remaining was that some of the main infrastructures were not properly set. Some of the dependencies were not available. Some software, some operating system had to be installed, and all the server configuration had to be done before you start working on it, because it's just the storage space and resource that they provide. There was no auto scaling. What about the securities and all those concerns? So then came serverless computing. Now we'll discuss afterwards what is exactly serverless computing. What I'm trying to tell you is that after cloud computing, serverless computing had all those functionalities, which is auto scaling. There was obviously no physical hardware needed. And a very big point here, which I would like to point out, is that it is cost effective, because comparatively, moving from physical hardware to initial cloud computing days to serverless computing, the cost has cut a lot. And you can think of this as physical systems, you can think of it like buying a new house. So when you are trying to buy a new house, when you are trying to, yes, you don't buy a new house, when you are trying to create a new house, I would say. So you work in bringing all the raw materials and try to do that, and you manage everything, which is not easy. And then just take cloud computing is like home rent, like you are rent, someone is renting you a house, so you do not need to go through the whole hustle, and now you just move in and you can start using your house. But then let's say that you are going out on a vacation for 30 days, and no one is using your house for a month, but still you are paying your rent, right? So that is what is cloud computing. The initial cloud computing days were more or less, and then came serverless computing. And you can think of serverless computing like an electricity rent. So however you use it, you only pay for those part, you do not pay for a fixed rent, right? And even if you don't use it for a month, there are some minimum charges, but it's comparatively, it's not that as much as what you would expect as buying the new house or if it's a home rent. So that's what I'm trying to convey here. So what is serverless computing? Serverless computing is actually a method, a model of providing all the backend services, not front-end services, only the backend services on an as used basis. So how much you use, you pay for that. And it is charged based on the computation, not based on what you reserve. So in the before serverless computing, many cloud providers had this model that if you own a resource, then you need to pay for it. And it was not charged based on the computation. Let's say your website or a web application that you have created is idle for a month and you are not using it. There is no pipeline going on. Then also you had to pay for that. And for in the case of serverless computing, it's not like that. You are only charged based on the computation occurs. And if the flow is idle, then you don't pay for it. And in serverless computing, physical servers are still used, but we just don't need to care about it, because just think of it like there are cloud providers who has to tackle these physical servers, and we are not the part of it. We only use the services, which is like the front end services, which means that everything will be done by them, and we will just start using the services to deploy our code and create web applications. So does serverless mean there are no servers? Because the name suggests that there's no servers in the computing model, and even if the name is ambiguous, it doesn't mean that there are just no servers. It actually means that we or user is not controlling servers. So it's just that they are not user specified or controlled. And this means that the development that we are going to focus, or we focus on serverless computing, that does not include the usual server process. So we do not deal with the servers. Instead, we rely on the third-party services, which are the cloud providers itself. And basically, if you are planning, just like the big firms, if you are planning for servers, then you can definitely create a hybrid architecture where there are servers in for some of the code base or some of the functionalities, and there are serverless applications for some of the other functionalities. So you can create those hybrid architecture and work around with it as long as it benefits you, because the main purpose of serverless is that it's easy, and then the task which requires computation can be easily performed using serverless. So you don't need to create servers and architectures. And all those tasks that we'll be performing with serverless technologies we'll discuss further. Now, how is this different from traditional cloud computing? I have already given you a hint before. So it's different in a lot of ways. First of all, we are not talking just about virtual machines here. So when I first started using cloud computing services and I was not aware of serverless computing at all, In the college days, I always thought that virtual machines are the only thing in cloud computing, and it's not it. There are a lot of new services provided which is so easy and so instant. You do not need to configure anything at all. So in virtual machines, in traditional cloud computing, you configure your whole server by yourself, you manage it, you maintain it. There are teams to maintain it, whereas here it's not. Then you pay only what you use in serverless computing, which is different than traditional cloud computing. In traditional ones, you are reserving things pre-development. So let's say that you are trying to buy a virtual machine or rent a virtual machine. Then before creating a virtual machine, it will ask you how much resource do you exactly want. And let's say 2 gigs of RAM at first, or 32 gigs of hard disk. That's what you want for creating a website. But what my point here is that till the time you do not use those resources properly, let's say your website only uses 500 MB of RAM and you have 2 gigs of RAM. So you are actually wasting your resources as well as money, right? So you are in loss. Whereas in serverless computing, you only pay what you use. There was no auto scaling feature in traditional cloud computing. What auto scaling means is that, let's say there are, in basic terms, I would go, let's say there are 100 users currently working on your website. And let's say suddenly there becomes 500 users. So your website needs to maintain the flow, right? Even if there are 500 users, needs to maintain the same speed, which is not easy if you do not have all those algorithms already made by yourself. Serverless makes this task easier because there are high performance algorithms already available. Because we are not just talking about one client or two clients. There are countless clients available in cloud providers. So they have some very strong algorithms already set up, which is an advantage for us. The advantage of serverless computing. First one is high scalability. Let me point out here is that we do not need to specify any size when we use serverless computing service. It's just unlimited for most of the services. So the more you use it or the more data there is, it will just adapt to itself. So it's highly scalable. You can increase the resources overnight. There is no problem with it because in the cloud computing model or in the early days when we used to have physical systems, we needed to buy some new hardwares. We needed to change the whole pipeline, the whole architecture. If we need to scale it, right? Here it's not the case. Then reliability and performance. It's totally reliable because, as I said, the providers have strong algorithms and it's based on distributed computing. So it makes it very reliable and highly performant. It's low cost, as I already said, because you only pay what you use. You don't pay for the idle time, which is a great point here, which was not the case in the early days. Then the code base is very simplified because it's a function as a service. I'll discuss more on function as a service, but in cloud computing model before serverless computing, there was no such thing as a function as a service. And believe me, how much effect it has made on this big firms and in the IT market. Then there is less focus on infrastructure. And when we say less focus on infrastructure, we mean less time to manage different architecture and pipelines. If it's not readily made, and let's say we are not using any serverless computing service or any cloud provider service, we are creating everything from our own, right? Then the company or any firm or any institute has to invest a lot of time into first creating the whole algorithms and whole pipelines. And then we need a team permanently to maintain those, which is not an easy thing. So here we are not focusing on the architecture because what serverless computing focuses is on easy deployment. There is no infrastructure that we really have to care about. Then no cost when functions are not running, as already said, and there is reduced latency. So the feature of geolocation comes into place here. the latency is greatly reduced due to the fact that users do not just direct it to one single server. There is no single location that the user's traffic is directed to, because there are lots and lots of servers and big servers provided throughout the world, set up throughout the world by these cloud providers, that it is always directed to the nearby server. So it reduces the latency we cannot even imagine of. And serverless services are small snippets of code basically. We use these snippets, we create it to perform a specific task which executes on pre-existing servers. So the servers are already made, the architecture is set up, all the dependencies are already installed, and there are many other customers using the same server for their own tasks. So basically we are using someone else's computer to do our work, and there is no setup needed. Cloud computing models. I know we were talking about serverless processing, but I think it would be very easy for us to understand serverless computing if we know a bit about cloud computing as well, because it's like an umbrella of serverless computing. So infrastructure as a service, backend as a service, platform as a service, and software as a service are all four models of cloud computing. Infrastructure means it just provides servers and storage. Backend means where a developer mainly focuses on the front end, and much of the backend tasks are already provided by the service, such as like DB management, database management, user authentication, hosting part. And then there is platform as a service, where database management is provided, servers and storage spaces are given, but an operating system is already installed in it, whatever operating system we choose. There is a software as a service, where cloud hosting applications, we directly use the application. But then it comes function as a service, which means that the provider only gives us access to create a function, and we can directly use that function as a service. So we do not use database, we don't want the software or platform. There is a space which is already given for us to perform function, and that is what we use basically. This is a bit out of the scope, but I would just like to point out that in software as a service, you can see that you manage nothing and vendor manages everything. So after software as a service comes function as a service, where basically it's almost same. We manage nothing and vendor manages everything. So now you know what is serverless data processing, right? I'll explain two scenarios to you which can give you some idea why do we need serverless processing. Let's say I want to create a web app in the simplest manner. I have an idea and I just want to implement my idea, the feature that I want. I don't want to manage my own server or any other infrastructure, and I want it to be brought to market as soon as possible. And I'm planning to use all the readily available tools which makes my life easier, and I don't want to spend time in doing the same thing again and again. So at that time, when my focus is directly on the feature, on the development, to bringing it in market as soon as possible, serverless comes into picture because it's easy deployment. You can basically deploy your app in minutes. Let's take another scenario where you run an organization and now you just don't want to create the whole architecture by yourself and the pipeline by yourself. You don't want a team which maintains that architecture. So at the end, it will save money, right? And your cost. So if there are readily available tools, you would be happy to take it. And at that point, serverless comes into pictures. It makes your and your employees' life easier, and you would definitely want to have that, right? So who provides these cloud computing services? There are lots and lots of different cloud providers, but some of them are mentioned over here. There is Oracle, Alibaba, IBM Cloud, Microsoft Azure, SAP, Google Cloud, Salesforce, AWS. These are the top 8 of the service providers, And there are many more, but we'll just discuss about Google Cloud for today's seminar. What I'm focusing on is not just one cloud provider. The functionalities which I will explain today will be basically available from all the cloud service providers. So it provides many technologies. There is compute, storaging, networking. There is cloud AI for machine learning. You can even integrate many devices using Internet of Things. For security, there is identity and security, which is IAM. And then there are some developer tools, which we are going to look into, right? So let's start with Google Storage. Google Storage was launched in May 2010. So it's been like a decade since Google Storage has been already launched, and many of you might not even have heard of it, or might not even have seen it or used it, right? We all must be knowing about Google Drive, but this is totally different. It's for development purposes. So it's an online file storage web service which is used for storing and accessing data. And every file here is called an object. So whatever type of file it is, it's not like SQL. You can import and you can fetch any file of any extension, but every file will be called as an object. And then there is a bucket. So bucket is just like a database. Bucket is a collection of all the objects. So you can assume it as a folder. It's a folder of a lot of objects, because we'll need to modularize our storage, right? So for that, there's an object, then there's a bucket, and then there are objects respective to it. And it works basically on REST API. You call through API, you pass objects, and it will do the work. It has high performance. It's highly scalable because it's unlimited storage. And let me give you an example. So let's say I want to create an application using React. React is a front-end framework. You might be knowing about it. And you assume you do not know any back-end language. Let's say Python or Node. You don't want to mess up with any of it. And you don't want any of the server, because you just have an application front-end framework that you're using is React, and you want a storage space which is temporary, not permanent, not like SQL or database that you would need. So then you would want to integrate your React with this Google Storage. That will be your solution, because if your application requires some temporary storage, let's say for like 30 minutes or 45 minutes, and then you want to fetch the data again, then this may be for you, right? And then there are different storage classes available based on your needs. There's a standard storage, which is good for frequently used data if you are using it for your websites. Then there is a nearline storage, which is good for the data is good for at least 30 days. Then there is a code line storage, and then there is archive storage. So based on what you need, you can use a different type of storage. And the advantage of it is that cost decreases as you switch from standard storage to archive storage, because as I already said, right, the more the computation, it will ask you for that price. But if your computation is less, if your idle time is more, the cost will drastically decrease. That's what this is all about. Then cloud functions. So the first service we already seen is cloud storage. The second one is cloud functions. And I would basically call this cloud function as a real serverless computing model, because this is where it all came from. It's a lightweight solution to create a single purpose independent functions, which basically means is a single function, and then it responds to all the cloud events and all these services. It also responds to your REST APIs. So if you call it through your API and then you want your result back, you already created a function in cloud function. It's pretty much easy. There is no environment management. Believe me, it's so easy. You have logic. You put that logic in cloud function, it will directly start working like a charm. It's a function as a service. That's what we discussed before, right? And all the functions can be written in Python, Node, Go, Java, Ruby. So there are many different languages. So when I started using it, there were only two languages were supported. But now Go, Java, and Ruby have started coming up, and hope that many other languages will be supported in the future. Then let's take an example of using Google Storage and Cloud Function. It's a very easy example. You have a React app. I'll be using React throughout this seminar because just to keep it as a standard. It's a React app. And now what you want to do is that, let's say you upload a document in your React app. And when you press a button, what you want to do is you want to count the number of lines of the code. Let's assume for now you don't want to do this part in React. We can do it obviously in React. Let's just say you want to use Google Storage and Cloud Function for it. Okay. So what you will do is that the first thing that you can see here is a bucket. So it's bucket one, which is already created in Cloud Storage, and you will upload a file from React to this bucket one, which is new file.txt, right? And it's a tree. And then you have already set up the thing like that. Whenever you upload any of the file on your bucket, a function will be triggered automatically. And that function will count the number of lines of that file. So as soon as you upload a file, a function will be triggered, and that function will use that file. It will count the number of lines of the file and it will give it back to React. So you do not need any backend language for it. It is as easy as you see here. Then comes Google Cloud SQL. So Cloud SQL, you might already be aware of it. It's relational database service for MySQL and PostgreSQL. You can easily connect it to any of the Google Cloud provider service like App Engine, Compute Engine, and it's also a REST API based. So you can directly connect your React app or backend framework with it. It's reliable, it's encrypted. You can easily migrate existing database to Cloud SQL. This is a big point here because let's say serverless computing came in 2015 and you already have a big database in your local machine or in your virtual machine somewhere. And now you feel like I cannot migrate the whole part of it in the Cloud SQL because it will be very cumbersome, right? So you can easily migrate it from existing database to Cloud SQL based on some services it has provided. And that's it. Then there is IAM. So IAM is a very important factor here. You use all those services, but all those roles and permission will be managed by this service. It's a cloud identity and access management tool, and there are admins who authorize who can take action on specific resources. So till now we have seen three services: storage, and then there is function, and then there is SQL. So let's say I only want to give some permissions for some people to Cloud SQL, and then some for functions, and then some for, let's say, specific functions, and then some for storage. So I can do that using IAM. You can manage roles and permission for hundreds of your projects and big organizational structures. And there are specific position employees, right? And every employee has its needed rights. Let's say there is a database manager. So obviously they will be having full rights to Cloud SQL, but then there are software developers, so who mainly tackle only backend and front-end tasks and do not need to have write permissions to Cloud SQL. So they will only have read permission. And every organization can do this at some level without using serverless computing. But look at how granular it is. You can give permission to any single module of your code base, which is not easy without this service. You cannot give specific permission to specific code module without using it. So that's how granular it is. And think about the time being saved here. If a new employee is hired, the admin will just set IAM permissions for him or her, and then they can access and whatnot. They can directly start working on based on their credentials, right? Then there is Cloud AI. So Cloud AI, you build, deploy, and manage machine learning models. So you at first, the need for this cloud computing services was that the resources were less. So if you want to train your machine learning model, you cannot train it on your physical system that you have, your local machine, what I mean to say, because the resources are very less. So you what you used to do is that you used to transfer your whole code base to a virtual machine which is having high computing power, and then you used to train the model. But after you train the model, there is nothing we can do about it because the cloud provider does not provide more than that, right? So now in cloud AI, you can basically build your model, you can deploy it, and you can meanwhile manage it. You can add cron jobs to it, you can add automation to it, and there is a tool which is AutoML. It's a zero code platform. So if you want to use some existing trained models, because let's say your application is based on image processing, and there are many different models already available in cloud AI which are trained based on some best data sets which you wouldn't be able to gather at the first place. So it saves a lot of time, a lot of cost here. You you just go there, you train, it's already trained, so you just predict based on your data sets, and that's all. In Google AI, it's one name, but there are different services provided under that name. There are four phases mainly in machine learning. You prepare your data set at first, then you build your data set, finally you validate it, and then you deploy it, right? So there are many services provided for each of the phase, data labeling, or if you want to build and train your model, or you use Wiser, and then you predict finally. So let's say you have a website where you upload a file to get a prediction. That website will pass through all these different services and then give you the result back. Dialogflow is a conversational AI. So you create AI agents, chatbots in a simple term, and then you can you you build and deploy your app in minutes, because there is no programming needed if you want to create a simple app. And it's everything is visual. So you just drag and drop, and you write some questions and write the responses, and easily you can just deploy them in Google Assistant in minutes. And if you want to create some complex applications, you can also add your code snippets. There are some languages which are supported for now, which is Python and Node. And why don't you try this? This is all these services that I mentioned. Some of them comes under free tag, which I'll talk later on. And this Dialogflow is actually free, so you can just go there, try it out, and within 30 minutes, I'm sure you would have created your first app, and then you can just deploy it on Google Assistant, and you can start using it the next day. This is the example I would like to present. So what happens here is that, first of all, my purpose of showing you examples is not that you can start developing from the next day. I know that everything does not get digested in just one day. Is that to show you all the capabilities of serverless computing and how easily we can achieve it. And who knows, if any one of you might have an idea to create an application, and this is what you have been missing the whole time, right? So that's the reason I'm showing you examples. So what happens here is that from the home page, user enters credentials, and then there is one FA validation occurs. So there is two-factor authentication this example is about. What it basically means is that in some of the websites, you must have seen that the first authentication is the login one, where it asks you for username and password. And then as soon as you pass to that phase, then it asks you a security question. The security question which would have been already asked to you when you would have signed up, and the answer should match to that answer exactly. So that's actually two layers of authentication, which is two factor authentication, right? So let's say you want to implement two factor authentication using cloud. You have a React app, and you already created it. There's a form. You click on the button after pressing username and after entering username and password. It goes to 1FA validation, and then it checks using GCP's service, which is Firebase. So Firebase is a service where you can have your data. Mainly, you can keep your usernames and password and everything, or any other data you want. And then there is authentication services provided by GCP Firebase. So you just fire up a query to GCP Firebase, and it will check if the username and password matches to what already exists when you signed up. As soon as you finish that phase, and it again goes to the home page, now it will throw you a security question. That security question, you would answer to that, and then that question will go to Cloud Function and Cloud SQL. So what Cloud Function will do is that it will actually fetch the data from Cloud SQL, the actual answer, and then it will compare it with the answer which is provided by the user. If all if the answers one or two questions answer matches, then it will give a yes, and then you are successfully logged in. So the here you have used no backend service. There was no backend framework which you used. You only tackled your task with three services, which is GCP Firebase, Cloud Function, and Cloud SQL. So it's all serverless here. Ways to use Google Cloud Services. You people must be thinking, I know it now, but how do you start using it, right? So on Google Cloud, you can use it using GSUtil library, which is already provided in Cloud Terminal. And you can also use it using your local terminals. Using the same library, it will definitely ask you for credentials for security, but it's easy to set up. And as you already seen, you can directly call it from your front-end framework, which is React, Angular, Vanilla JS, or whatever. And if you are using some backend framework, so let's say sometimes you just don't call it directly from your front-end service. Your front-end framework has been integrated with your backend, and you can even do some computations in backend from your own, and then you can fire up a query to use these Google Cloud services. If the code base is already existed for so long, and you just don't want to migrate the whole part of it to Google Cloud, right? So enough about Google Cloud services. What is AWS? So every service that I already mentioned here relates to this, because Amazon S3 is exactly the same as this. The main purpose is exactly the same as file storage, Google file storage. Then Amazon RDS is same as Cloud SQL, and AWS Lambda, which is a very big term because it's a very important term for AWS. It's same as Cloud Function. We'll take an example here. So let's say there is a browser application, and through Amazon API Gateway, which is one of the service provided by Amazon, you go to S3 bucket, which is a file storage system, and then you go to AWS Lambda to process all these things. So the normal flow of it is that every time the application uploads the data, that data goes to S3 bucket, data gets stored, then it triggers AWS Lambda every time the file gets uploaded. It automatically gets triggered. And then that Lambda fetches the file from S3 bucket, processes some things, and then finally it interacts with DynamoDB here to store the file. If it's not for storing, it will give it directly back to browser application to after processing to give some returns or some results, right? Just to note here is that Amazon CloudWatch is a monitoring service. So everything that you do here, because in serverless computing, it's the code base is not at a single place. It's actually distributed. You have some code in AWS Lambda, then you have some code in your notebooks, some code in some things under the S3 bucket, right? So whatever happens, if you want to debug it, you can debug it using Amazon CloudWatch. Every action is monitored and logs are being kept over there, right? So what this app basically does is that it uploads the data to S3 bucket, and then based on the triggering event, Lambda fetches that file, processes things, and you can see it is interacting with Amazon DynamoDB. So either it saves it to DynamoDB, which is based on relational database, or it interacts with these monitored services. And this Elemental, Media Live, and all those services, which I will not go into deep, are live video processing services. So this example which I have taken is that the files will be processed, files will be in the form of video, and it will be processed, and then it will be packaged and delivered back to the browser. So that's what this real case scenario is about. So enough about the advantages of serverless computing. Everything has its disadvantages, right? And what are the limitations of serverless computing, right? So let's go into some of these. Security is a very big issue in cloud computing, not just in serverless. It's an issue of cloud computing, because just imagine you have, as I already said, there are pre-existing servers, and these servers are actually used by countless customers, and each customers have their own task. So if everybody is using the same server, there are chances of leakage if it's not properly set up, right? It's like everybody is living under the same roof, under the same house, which is not good. And then there is vendor lock-in. So this is a very big limitation. What happens is that, as I already said, the code base is not at just one place, it's distributed. So there are different places where you keep and you place your code bases, your code snippets. And now let's say you want to switch from GCP to AWS, you want to go to a different cloud service provider. You cannot just do it in one day, because it's not that easy. The APIs that you need to transfer, and then the whole code snippets they need to transfer to different services. And who knows, that same service is not being provided by the different cloud providers. So what? They have to think about ways how to solve that problem and all. Then debugging is more difficult. And the reason is that as the code base is not in a single place, you cannot just directly debug the code, right? You cannot just put a breakpoint over it and then see when the breakpoint arrives and just check it, because there are different small services which are integrated, and the whole flow is actually real time. So you cannot just take out a single service and then start debugging it. There are some ways, but it's not that easy, what I'm trying to point out here. So as I said, security is a big challenge. Some big security risks are function event data injection. So what it means is that you already seen AWS Lambda and GCP Cloud Functions, right? Which accepts the data. So you fetch the data from the buckets. So what if there is a malicious file which someone already uploaded from the website, and you take it using your function? The function is actually in the backend, it's in a server, right? And that server is being used by a lot of different customers. So what if the file is malicious and it just does something which we do not want? And there are DDoS attacks, the attacks which increases the traffic flow, and the traffic flow does not stay normal. It just gives a lot of computation tasks. The traffic flow just increases in a lot in seconds in DDoS attacks. There are many different attacks which comes under DDoS, but I'm not going to explain those because it will be a security based seminar then. That comes insecure third-party dependencies, insecure serverless deployment configuration, and a lot of different security risks. And there are always ways to improve this security because nothing is safe when you start using internet, right? And that's what the challenge is. You don't get everything you ask for, right? Maybe that is where a chance of research lies. Believe, um, believe me, when I was studying, I was always looking for some places where there is loopholes. I was always looking for things which is not yet created so that I can do something about it. So to all the researchers here, I would like to point out that this thing is a big drawback of serverless computing, and then there is a big research going on currently, and then there is a chance, right? So what is the future of serverless computing? The market size is already growing. It, ha- it has grown from 1.88 billion in 2016 to 7.72 billion by 2021. So that's what predicted by one report that I have read, and the reference is already provided. And even after this pandemic, the growth has been tremendously better, and the growth is 32.7% per year, right? So it's not small thing. Amazon has 70% market share with just AWS Lambda. AWS Lambda, as I said, is the main part of serverless computing. And look at the market share here. So serverless computing can change the whole way we do business. It can make our business smarter and faster. It can save you a lot of cost, a lot of time. Some other services which are under serverless computing, we have discussed few of those, which is just the beginning point of it. And then there are a lot of different ones. Let's say, such as Google Cloud Run, which runs stateless containers. So if your code base, you can just wrap your code base using containers, which makes development for employees in the firm, as well as you can just deploy it using Google Cloud Run, which is so much easier compared to the traditional methods that we were using. Then there is App Engine. PubSub is a publisher subscriber model. It's actually a real-time messaging services based on a different kind of approach. Then there is AWS Comprehend, which has NLP-based functionalities. So if you want to deal with natural language processing, some inbuilt provided functionalities in AWS, that's what you can use. Enough about serverless computing. What about the job, right? So what are the job opportunities do I have in this field? And there are many companies which have already started or have already migrated some part of it or the whole part of their code base and whole infrastructure to cloud provider platforms. There are immense opportunities if you have hands-on experience. It's not theory, because there are, as we already seen, there are a lot of different services provided by cloud providers in Google or in Amazon or in Azure, and every company uses a different ones. Let's say one company uses Microsoft one and the other company uses Google one. So you need to have that hands-on experience that you have already used those things, right? Even if you are planning to become a software engineer or cloud engineer, ML engineer, data scientist, every position is related with cloud. The reason is that even if you are a software engineer and you say, I only want to deal with code base, but what if the whole code base is in GCP or in AWS? The whole code base is written in AWS Lambda, right? So you need to have that hands-on experience. It's not just theory. And then there are a lot of different services currently in research by these big cloud providers that we will be able to see in future. Some more examples, but so what this basic, I'm not sure we have enough time for this, but what this does is that it's a retail data warehouse ETL. So if you are interested in data warehousing, these services can help you to create an application based on data warehousing. There's an online order which is placed and it goes to DynamoDB, which is a database where the data is stored. then which triggers AWS Lambda, which performs some computation. And now there's a new service from AWS, which is Redshift. So Redshift is a data warehousing tool. It collects data from different places and it warehouses it. And then there are analytics generated from this data. A lot of different use cases which you might find under this link that I have provided, big data use cases. And it's immense. Like, let's say for this one, this is based on real-time streaming, and then there are batch updates. So if your application needs real-time streaming, you can use AWS Kinesis, which processes real stream data, and then the data is finally put in DynamoDB. And if you have a batch updates, you can use Amazon EMR for which it's somehow works just like Apache Spark or Hadoop, which you might already have heard. So EMR is a service where you sort, aggregate, and join all the data set. You use MapReduce approach, and you process that data into Amazon Redshift, and finally you make some business decisions out of it, right? So, summary. We have a lot of things we have touched in this seminar, which I would like to just brief you again. Serverless computing, what it is basically a function as a service. A function is provided by the cloud providers, and you integrate those functions directly with your code, front end code or back end code, and that function does some task. It returns some value that is helpful for you, right? So there is no, even if you do not have any backend server attached with your application, you can just directly use your functions, use these cloud provider functions, and work around with it. Then we discussed about cloud storage, cloud functions, cloud SQL, and its analogies in AWS, which is AWS S3, AWS Lambda, and AWS RDS. We notice that security is a very big limitation in serverless processing, but who does not have limitation? And there are always ways to get past it, improvise the security, right? It's serverless provides easiest app management and deployment. So you can deploy your app in seconds because you do not need to configure any of the server part of it. No infrastructure setup is needed, right? That is the beauty of it. And then you only pay as you use, because as you already discussed, in the traditional cloud computing and before traditional cloud computing days, this was not it. Whenever you plan to create an application, the first thing that comes into your mind is how much expense it's going to take, right? So how much money, what's the real cost, how much employees. So this serverless computing model decreases every one of those things, because you do not reserve for anything upfront. You only pay for what you're using. So even if your application fails, your startup fails, your idea fails, right? So you're not in a loss. There are many more ways to learn more about what I've already said. AWS, Google Cloud, and Azure provide some very good documentations for each of the services and how to use it. Also, there are many free tier services to have hands-on experience. So all of the services which I mentioned, you can use most of those services using free tier accounts. And for students, there are specifically educate accounts available. So they give you some about $300 or $400 to use for a year in these services, and you can actually use each and every services using the resources that they provide, which is really great. So you can have hands-on experience, and you can learn, and you can explore more of the stuffs. So these are the references of the contents I have used in the presentation, and thank you. It was about 50 minutes, but I hope you bear with me. I'd like to hand it over to Magduma ma'am. And if there are any questions from people, I would like to accept them and answer some of these.
Yes, Harsh, we have some questions. Just as you told, this is the cost effective, right? The scenario is cost effective. So, under which specific case or scenario it should be avoided?
Under which specific scenario this serverless model
Yes,
should be avoided?
even though it is a cost effective.
So I actually cannot think of any specific way for which it should be avoided. But as I said, security is a big limitation. So let's say if you have an application which needs very much security, and as I already said, there are a lot of customers which are already using the same server, and you are not ready for it, then I think you at that point you should not use these serverless computing services. And also, if the code base is very big and it's an existing code base and migration takes up a lot of tasks, then I think you should avoid doing it for now. But then I personally feel that at some point in the future, every other firm is going to use even at least one of the cloud services, because that's the future we are talking about.
Okay, thank you so much. And one more questions. Like, which platform is good for the serverless computing? Like Amazon or Google, or that is depend on the application.
I have personally used Amazon at first, and Amazon is very good if you are just planning to start learning about it. And truly, there is no such difference in the service that they provide, but Amazon has a very large market share, so that's what I would like to point out. But if you use Amazon services and then let's say there is a job opportunity in Google for Google cloud platform service, then it does not make a whole lot of difference. You can just get used to it instantly because you already use the service and it uses the same architecture. It's just a different name and a little bit change. But I don't think there's a whole lot of difference in all those services.
Okay, thank you. And one last question: is there any difference between a cloud container and the serverless computing?
There is a difference between cloud container and serverless. So cloud containers are it comes under serverless computing. It's a very different domain. So as I already said in the presentation, there is a service called Google Cloud Run. So that service uses the stateless container. So you basically you have your own code with a, a particular environment setup, right? So you wrap it up using your Docker container, and then you deploy it using Google Cloud Run, and it makes it very easy for an organization or for an employee who is a developer to use the Docker to build the app as well as to maintain it. So containers are used for that purposes, which comes under the umbrella of serverless computing. It's like one of the services of serverless computing. It's not it's it's not different.
Okay, thank you so much. So thank you so much, Hers, on behalf of Computer Science and Engineering Department and the entire Parul University. Thank you so much. It is really a very informative sessions, and I hope students learn so many new terminologies from your session. So thank you so much once again.
Thank you very much.